Yeah, we'll see interprocess communication. Okay, there will be processes executing concurrently in operating system, maybe like executing independently or maybe cooperating processes. Okay, there will be in operating system two or more processes will be executing concurrently. Okay, operating system will be having many processes. In that processes, within the operating system, they may be independently executing or some may be cooperating processes. Okay, here independent process means the independent process cannot affect or be affected by the other processes executing in the system is called independent process. That means that the process which will be executing, it will not get affected by other process in the system. Not only that, the process will not affect the execution of other process in the system is called independent process. Okay. Next, we have another types of processes which will be executing in the operating system are cooperating processes. Cooperating process means the process that can affect or be affected by other processes. Okay. That means a process which will be uh, affected by the other process which are running in the operating system, and the process which can also affect the other process execution in the operating system. That process is called cooperating process. Understood, right? Independent process means which will not affect any other process and which will not allow other process to affect itself. Okay, that is independent process. Next, cooperating process means the process can affect or and it can be affected by other processes also. Okay, it will a process will it may also get affected by other processes, or the process itself can also affect other process execution. It's called cooperating process. Okay, there will be many processes which will be executing concurrently in the operating system. That process will comes under either independent process or cooperating process. Okay, we can say like independent process means any process that does not share data with any other process is called as independent process. We can say it is an example for independent process. A process that does not share any data with any other process in the operating system. That process we can say it as independent process. Like the same way for cooperating process, we can say any process that shares the data with other processes, okay, is a cooperating process. Okay, if a process which will not share any information is called as independent process. The process which shares information with other process, we can say it as cooperating process. Okay, these are the two processes in operating system. Okay, operating system, there will be many processes executing concurrently in the operating system. That may be fall into either independent process or cooperating process. Okay, and here we have, there are several reasons for providing environment that allows process cooperation. Okay, to allow to provide the environment for process cooperation, there are several reasons. In that, first reason is information sharing. Okay, information sharing means there will be several users may be interested in the same piece of information. Okay, there will be many users want same information. Okay, so an environment must be provided to allow concurrent access to that information is called information sharing. Okay, there will be many users who wants the same information. That time we by using the cooperating process, we'll be providing an environment, okay, that will allow all the users to access the information concurrently. That is information sharing. Okay, next one is computation speed up. Computation speed up means if we want particular task to run faster, okay, that time it can be broken into subtasks, and each of which will execute in parallel with other. Okay, so if you run a task as a complete process, bigger process, that time it will take more time to execute. Okay, only one process can execute the one processor can execute a one process. Okay, like if the process itself is too big, if any other process may be waiting for resources from this process, that will be keep on waiting to complete that complete process. Okay, so to speed up the computation, we can uh, break down the process into sub process. Okay, each will be executing parallelly with other. That time automatically the process execution will be very fast. Different now the all the sub processes will be executed by different processes, different processors. So execution will become very fast. Okay, in that way we can achieve this computation speed up. Okay, next one is modularity. Modularity means if the system is to be constructed in a modular fashion, then the system functions can be divided into separate processes, okay, or threads. Okay, if the system wants to be constructed in a modular fashion, then the system functions can be divided into separate processes. Okay, each function of the system will be, we say it as separate process that will be executed by separate threads. That is called modularity. Okay, next one is convenience. Okay, an individual user may work on many tasks at the same time. Okay, that will provides the convenient for the user, convenience for the user. Okay, these are the reasons for cooperating the process. Okay, these are the reasons for providing environment that allows the process to be uh, process cooperation, that is information sharing, computational speed of modularity and convenience. Okay, understood this. Here in interprocess communication is required in cooperating process. Okay, cooperating process needs the information interprocess communication mechanism. Okay, cooperating process requires interprocess communication mechanism that will allow them to exchange data and information. Data will be exchanged or information will be exchanged by using the interprocess communication mechanism. Okay, the cooperation between the processes will be achieved by using the interprocess communication mechanism. Okay, and here we have two fundamental models for interprocess communication, that is shared memory, other one is message passing. Okay, we'll see with the diagram. Shared memory. Okay, shared memory we can see here. We in the memory we will be having the kernel, and we have the different processes, that is process A, process B, and we have a shared region of memory. Okay, here in shared memory, a region of memory that is shared by cooperating processes is established. Okay, region of memory that is shared by cooperating processes is established here. Here, this is the shared memory, and which will be shared by the process A and process B. Okay, the processes then exchange information by reading and writing data to shared region. Okay, here you can see in this example, process A wants to communicate with process B. It will, process A will write to this shared memory. Okay, and the process B will read that information from the shared memory. Okay, process A will write to the shared memory, that will be read by the process B. In this way, the process A and process B will get communicate with each other in shared memory systems. Okay, we have another system called message passing system. Okay, in this message passing system, you can see in this diagram, we have the process A, process B, and we have the kernel. Okay, and here M represents the messages. Okay, here in this message passing system, the communication takes place by means of message exchange between the cooperating processes. Here the communication will take place by using passing of the messages. Here the how the messages will be passed. Here the process A passes a message to kernel. Okay, the kernel will pass that message to the process B. In this way, the process A and process B will be communicated with each other. Okay, process A will communicate to the process B through the kernel. Okay, whatever message the process A wants to be communicated with process B, that it will send to the kernel. Okay, kernel will send that message to process B. Okay, this is message passing system. Understood, right? Shared memory system and message passing system. Shared memory system will be having a shared region of memory. Okay, that will be shared by both the processes. Okay, and messages help to communicate with each other in the message passing system. Okay, where in message passing system, both the process will send a message to the kernel. Kernel will send the message to the receiver of that message. Okay, that will be done by the kernel here in this message passing system. Okay, this is the diagram for communication models diagram, message passing and shared memory. We say difference between these two models, whereas message passing system, it is useful for exchanging the small amount of data. If the data is very small, we can use this message passing. So every time the message should pass to the kernel, kernel will send that message to the receiver. Okay, receiver of that receiver is nothing but is another process with whom the process A wants to communicate. Okay, this message passing system is useful for exchanging small amounts of data. If it is large amount of data, if you want to exchange, better we can go for shared memory system. Okay, and this message passing system is easy to implement, whereas shared memory system is it is complex to implement. Okay, whereas this message passing system, it is slower because the message first sent to the kernel will send the message to the process B. Okay, it is slower. Whereas the shared memory system, whatever information process A wants to send to process B, it will write to the shared memory. From the shared memory directly, the process B will read it. Okay, so this shared memory system is faster. Okay, next one, message passing system implemented using the system calls. Okay, whereas shared memory system calls are required only to establish shared memory region. For that purpose, we use only the system calls only used to establish the shared memory region. Okay, and here for everything we use the system calls. Message passing the message will be sent to the process B. For that, we'll be using the system calls in message passing. This is about interprocess communication.